Okay, so in this section, this is where it might get a little bit challenging. These are what I like to call kind of like puzzle problems. We are going to simplify trig expressions, and that's going to actually leading to helping us solve different trig equations. It's the same idea with a rational function. So for example, we could have something like x plus 2 over x squared minus 4. Well, that's the same as x plus 2 over x minus 2, x plus 2, right? Well, we can simplify this, and the 1 over x minus 2 is easier to work with. And we're going to do that with trig expressions. The next thing that we're going to do through this is we're going to prove trig identities. I'm going to warn you, some of you who maybe don't practice as much as you need to, this is one of those sections where you have to practice in order for this to make sense, okay? So here's the trig identities that we kind of already know. And these are reciprocal functions, right? We know cosecant and sine are reciprocals. So that means that cosecant is going to be the same as 1 over sine. These are equal to each other, okay? Secant is the same as 1 over cosine. Cotangent is the same as 1 over tangent. And tangent has two kind of identities, right, which is sine over cosine. And so there's a certain point in time where we're going to go ahead and we're going to have to substitute these guys in and see if anything can reduce. And so another way to look at this is we're reducing fractions. And don't let the CSC or the SEC or the tangent or the cotangent trip you up. Here's what I'm going to tell you. Is if I had the word apple, right? And I said apple is equal to orange. Okay, I know this sounds silly. And if I had orange over apple, you could replace apple with orange, and that would equal 1. So think of these as just objects that are the same that you can reduce and work with. Now, we need to know what each one is equal to in order to do the substitution, so there's a little bit of memory that's involved. Let's move on. We're going to talk about these Pythagorean relationships first, and we're going to use these to actually discuss our first introduction to Pythagorean, to working with trig functions and doing a little bit of proofs. Okay, so a couple things real quick. This is our first one. Okay, and this one actually comes from our unit circle. Unit circle is a center of 0, 0, and the radius is equal to 1. Well, in trig, though, y is equal to sine, and x is equal to cosine, so I just plug those guys in, and that's how we get the first one. Okay, well, how do we get the second one and the third one? How can we come up with these? These are all technically the same identity. Depending on what's given to you, you might use one over the other, but they're all the same thing. Okay, so we can get the other two, so we're going to derive the other two trig identities using this guy. And okay, so now let's look at number 2. Okay, so number 2. Okay, so we're gonna use this guy to get 1 plus tangent squared theta equal to secant squared theta. Okay, so one of the quick ways I'm going to look at, how would I maybe get 1 to equal secant squared? Okay, well, look at your notes. What is secant equal? We notice that, okay, well, secant, that's an E, of theta is equal to 1 over cosine of theta. And so by that same rationale, If I had a square here, we would just put a square there, and it's the same thing. Okay, so don't worry about using the square. Okay, so now, erase that, get that off of there, and kind of clean it up a little bit. That tells me how I can set up my substitution, if you will, to create this formula. Okay, so I look at this 1 right here, and if I divide it by cosine squared, it's going to equal secant squared. Okay, so let's do that. So I'm going to write sine squared theta plus cosine squared theta is equal to 1, and then I'm going to divide that by cosine squared theta. Well, what I do to one thing in an equation, I got to do to everything. So now we look through this, and we're going to look at this guy, and we're going to say, okay, well, we know that guy's secant, right? Because that's how we started the problem. Well, what's sine over cosine? Well, sine over cosine is tangent squared. So sine squared over cosine squared is tangent squared. Okay? What's cosine over cosine? So cosine squared over cosine squared, well, it's the same thing over the same thing. That's 1. We already know that that's going to be our secant squared. And so notice, by dividing everything by cosine, we were able to get our second formula. So, on to the next one. So we want to use our sine squared to get 1 plus cotangent squared theta equal to cosecant squared theta. Okay? So that means, how do we go from here to here? We would divide by sine, because 1 over sine is the same as cosecant. So I'm going to go ahead and take sine squared theta plus cosine squared theta is equal to 1, and divide every single term by sine squared. And that's going to equal 1 plus cosine over sine is cotangent. And because they're both squared, I plop a square in there. And because this bottom guy is squared, it becomes cosecant squared. And that's how we can derive actually all 3 of the Pythagorean identities. And this is this is an introduction to how we would use trig identities to create some other thing that I can work with.